another episode of Math in Motion,
where numbers make sense and sometimes tell jokes.
I'm your host, Maddie T.
And I'm Mrs. Z.
Today we're going on a little trip, a direct variation vacation.
So pack your graph paper, your pencils, and maybe your calculator. Make sure it works this time, because we're diving into what direct variation really means.
Hey, Ms. Z, can you tell our listeners what direct variation is?
Sure, I'm so glad you asked. So imagine this. We start a lemonade stand, and every cup we sell is $2. So if I sell 1 cup of lemonade, then I'm going to earn $2. If I sell 2 cups of lemonade, then that would be
$4.
Yes, and if I sell 3 cups of lemonade, then that would be
$6.
Exactly. So pretty soon you realize your money and your cups sold are doing the same dance. The more cups you sell, the more money you make, in perfect sync. That's what we call direct variation.
So when one value increases, the other increases at the same steady rate. Or in math terms, we could say y equals kx.
Exactly. So k is your constant of variation. So basically, this is the rule that says how fast y changes when x changes.
In our lemonade example, k equals 2 because every cup sold x, your money, y, doubles that number. So y equals 2x.
Yes, nice and simple.
Ms. Z, are you ready for a joke break?
Yes.
You know it's not a direct variation?
What's that?
My motivation and the number of math problems I have left on my homework. Those go in opposite directions.
Anybody else feel the same way? Yes. All right, so since this is supposed to be a direct variation vacation, how can we spot direct variation out in the wild? Let's check a few examples. So example 1 is the equation y equals 4x. So if we were to plug in 0 for x, 0 times 4 gives us 0. So because this line goes through the point of origin, then that means it has direct variation.
So the constant of variation would be 4.
Yeah, because that was our rule to get from our x to y. We just multiplied by 4.
Perfect. So example 2, you notice kind of the same thing, except to get from x to y, we're multiplying by a half. We still cross the origin, and we're still having a direct correlation between our x and y values.
Exactly. So this time, we're just multiplying by 1/2. So it's slower growth, but y is still increasing as x is increasing. Let's look at another example. So this example says y equals 3x plus 5. Uh-oh, that plus 5 ruins it. The graph doesn't go through the origin. If I plug in 0 for x, we get 5 for our y value. So because it doesn't go through the origin, it does not have direct variation. You ready for a joke break?
Yes.
By adding 5 to your direct variation, it's kind of like adding pineapple to pizza. Controversial, but definitely changes the flavor. What do you think about pineapples on pizza?
I'm not a pineapple on pizza kind of girl.
No?
No.
We now like to pause to give a special thank you to our sponsors. The first sponsor is Texas Instruments. Without you, our students would not have those amazing calculators to help them be successful in math. Our next sponsor that we would like to shout out is Country Time Lemonade. Without you, our example would not have worked out so great at the beginning of this video. We would now like to introduce our next guest into our podcast today. His name is Mr. Jude. All right.
Nice to have you, Jude.
Yes, so glad that you're here today. Can you tell us a little bit about what you do for our school?
Well, I do custodial work. I clean classrooms, I clean restrooms, I clean the gym when they have games.
Okay.
On
Thank you.
Tuesdays and Fridays, I do the bleachers, sweep and mop, and then I high dust, and
Awesome.
vacuum. I do pretty much a lot of
So you just
custodial
take
things.
care of our school so that we can come here to a clean facility every day and
That's
learn.
correct.
We appreciate you.
We
Thank
do.
you. That's correct.
Yeah, thank you for everything you do.
Appreciate
So
it.
today we're talking about direct variation. And so we wanted to think about how this kind of ties into your line of work. So can you tell us,
About how long it takes you to clean each classroom?
yeah.
maybe 10 to 15 minutes. 15 minutes is my target time, but I
Okay.
try to get 10 minutes at least.
All right, so let's apply this to our lesson today. So it takes Mr. Jude about 15 minutes to clean a
15
classroom.
minutes, that's
So if he has one classroom to clean, how long would that take you? 15 minutes, okay?
15,
So if he has 2 classrooms to clean, how long would that take him?
30 minutes.
30 minutes, there you go. And then if he had 3 classrooms, that would take him?
45 minutes.
45 minutes.
Exactly. So there is a direct variation between the number of classrooms he cleans.
And
And
I
how
have
much
maybe,
time?
And I have maybe 32 of them to do.
Oh,
Oh,
wow.
Yeah.
Yes.
So what would we need to do to calculate that?
Yeah. so
Yeah, that's a
it's
great
a lot.
question. Okay, so
15 times 32.
yes.
Yeah.
All right. Well, thank you so much for being on our podcast
Yeah.
today.
Thank y'all.
We
for
are
listening.
appreciate you.
Yes,
Thank
yes.
y'all for having me.
All right. All right, let's imagine the graph for a second. Every direct variation graph is a straight line through the origin. So it looks like this.
The line can be steep if k is big, or gentle if k is small. But it will always start from the origin, which is 0.00. That's because when x is 0, y times k
Y equals K
K
times
times
0,
zero.
which is just what?
0.
Magic.
Hey Missy, are you ready for a joke break?
Of course.
If your direct variation graph doesn't go through the origin, it's basically saying, sorry, I'm taking a detour.
Ah, that's funny. It just went this way instead of through the origin. Oh my goodness. All right, let's make this real. Direct variation happens all the time. So think about it as like the amount of money you earn and how many hours you work. So if you're paid hourly, let's say you get $25 an hour, that is a direct variation because 1 hour would be $25, 2 hours would be $50, and so it has a constant rate that it is changing.
Perfect. Just like when you probably see a lot when you're headed to school. The distance you travel is going to equal the speed times the time. So if your mom is going 70 miles per hour, that's how fast she'll travel every hour, unless she hits the brakes.
Or if you go grocery shopping and maybe you want to buy some candy bars, the total cost is going to be the price of the item times however many items you buy. All are examples of direct variations. If one doubles, the other one doubles too. Unless, of course, you're talking about your snack stash, that always disappears at triple the rate you expect.
Especially chocolate.
Yes.
Okay, time for a mini direct variation showdown. I'll say a situation and you decide, is it a direct variation or not?
Okay.
The cost of apples is $3 per pound. You buy 2 pounds, then 4 pounds, then 6 pounds. Is that a direct variation?
We'll give you a second to figure it out.
Right? We phoned in our listeners and they said yes. That is a direct variation. The cost equals 3 times. The constant of variation would just be 3.
Exactly. We would just multiply 3 times however many pounds we bought. All right, let's try a different one. So you start with $10 and then you earn $5 per hour walking dogs. Is that direct variation? Nope. Because of that starting with $10, the equation would be y equals 5x plus 10. So it wouldn't go through the origin, and so therefore does not have direct variation.
Okay. What about the number of text messages you send and your phone bill? Depends on if your plan changes per text, then yes, it's a direct variation. If you've got unlimited texting, then no. Lucky you.
All right, Maddie T, are you ready for a joke break?
Yep.
All right. If my phone bill were directly proportional to how many TikToks I share, then I'd be broke.
Especially watched.
Oh gosh, yes.
So what did we learn on our direct variation vacation today? Let's recap. A direct variation is when y changes at a constant rate with x.
It is written as an equation as y equals kx, and the graph will go through the point of origin, which is 0, 0.
K is your constant of variation. It is the rule connecting x to y.
And if it's not going through the origin, then it's not invited to the direct variation party. Thanks for tuning in to Math in Motion.
Remember, math isn't just about numbers. It's about the patterns hidden in plain sight.
And hey, if you ever feel lost, just remember, even graphs start from 0. See you next time. Oh, that wasn't too bad.
We have a lot of editing.